Hello grade 12s, welcome to my channel, and I've just received a copy of your exam that you just wrote, and I figured let's just have a look at it and jump into Euclidean geometry. I mean, I've skimmed and scanned this part of the paper. It looks fairly standard textbook stuff. Analytical geometry, not really that fancy, but we may have to look at it later. Trigonometry was also fairly standard. The trig graphs, we're going to look at all of them, but I want us to charge to Euclidean geometry, which is the part that often gives you guys a little bit of a challenge. So obviously this one is a proof, so you just draw a diameter. Okay, with this one you just draw a diameter. You only draw that thing. I don't know, you know, some kids like to manipulate my things. I don't know. Anyway, so all you do there, you just draw a diameter, COE, for example, COF, let's say, and you join this back. What angles are we supposed to prove here? DCE, DCE, wait, BCE, BCE. So we want to prove this angle to be equal to that. So that means we've got to join this one as well. Okay. So what you can do, you just leave these things as they look. Sometimes it's nice to say this is 1, this is 2, 1, 2. I think that's about it, because you don't need a lot. So after that, you will see this is the angle in the semicircle. It's going to be 90 degrees, which is that angle plus that. And then we've got this one here, which is 1 into 90 degrees, 10 rad. And essentially, if these two add up to 90, we can equate the two and use the elimination method. But we will see that this C1 is going to be equal to A1. These are angles in the same segment subtended by arc FB. Therefore, they will cancel out and leave us A2 is equal to C2. And that's how that is proven. So I showed my kids just before the exam, the day before, how to prove this theorem. I'm sure they were so happy, because yeah, sometimes not knowing what's coming is not good. But I showed them what was most likely going to happen. And here it is, easy and cheap. 5 marks then. Now in the diagram, we're going to do 8.2. In the diagram, PQRS is a cyclic quadrilateral. PQRS is a cyclic quad. That is pretty obvious because all vertices touch the circumference. And then RQ is equal to RS, that is also indicated. ST is a tangent to the circle at S. Perhaps we want to make sure we keep it in sights, okay? That is a tangent to the circle at S. And immediately when we see a tangent, we know that the 10 chord theorem is coming in. So it's going to be equal to that angle. That's the 10 chord theorem. Okay. That's at least what we can say. And obviously, seeing that this is an isosceles triangle, that is also going to be equal to that. Right. These are angles opposite equal sides. In a triangle, or since this is a circle, you can say these are angles opposite. Angles subtended by equal chords. Okay. Nice and easy. And then SR is produced to N. SR is produced to N. If that is the straight line, we can see that 10 chord, not 10 chord, but the exterior angle of a cyclic quad it means R2 should be equal to P. This is the exterior angle of a cyclic quad, and these are angles on a straight line. We can work out R1 also. Alright, so R2 is 68 degrees. That's easy. So this diagram is fairly simple, so we don't want to do too much. It says determine with reasons the size of angle P. Sorted. Can you see, just analyzing the diagram a little bit, you answer most of the questions. Angle P is going to be equal to angle R2. What is the reason there? Exterior angle of a cyclic quad. At least there's only one cyclic quad here, so we don't need to specify. Therefore, our angle P is going to be 68 degrees. So that's a nice answer there. So usually statement and reason and the value gives us those 2 marks. 8.2.2. We need to find angle Q1. Angle Q1 is literally, if we look at it, Q1 and Q2 are equal. But if we look at this triangle, we see that this is an isosceles triangle, meaning S2 is equal to Q1. And this angle R1 is an exterior angle of that triangle. So we can use that property. We can just easily say in triangle SRQ, what do we see? We can see that angle S2 is equal to, maybe let's use Q1 since we are interested in Q1, is equal to angle S2. These are angles opposite equal sides. Okay, we were given that SR is equal to RQ. All right, so that is important. We can say, however, we are aware that angle R1, or maybe let's put this one side by side. We are aware that angle Q1 plus angle S2 should give us angle R1. What is the reason? This is an exterior angle of a triangle. Again, we are speaking about that triangle, so we don't need to explain further. We can say that implies that now S2 is equal to Q1. We can say 2 angle Q1 is equal to R1 is 68 degrees. Okay, therefore we divide by 2. We can see that our angle Q1 is going to be 68 degrees divided by 2, which is going to be 34 degrees. So I bingamakray nice la sengiyabona impela. So usually, I mean, there's plenty of stuff here that one can say. Yeah, both these reasons come from grade 9, so it's a bit technical. So this is great. I think that realization though is pretty intense. I guess those 2 marks come from that statement and reason, and then the other one is just a means to an end. Okay guys, not a big deal. So let's move before we lose too much time on nothing. S1. Now we need to find S1. Can you see the 10 chord theorem saves us here? So we know that angle S1 is equal to angle Q1. The reason is the tan chord theorem. Therefore, that becomes 34 degrees as well. All right, not a big deal. So that is it, guys. Easy 6 marks there, because we didn't do the proof. But again, there's no way a student is not getting that mark. Okay, so let's see. What does question 9 have for us? So yeah, that was pretty easy, the first one. It's usually very easy. In the diagram, AB is a diameter. Okay, of the circle with center F. Okay, these are pretty good stuffs to ensure you've got under control. So if this is a diameter, this AB, it simply means it subtends a right angle at circumference. That's the angle in the semicircle. Angle in the semicircle. I don't know, it doesn't come out nicely. Okay, there it is. And AB and CD intersect at G. Okay, that is fine. FD and FC are drawn. FC and FD are drawn. Okay, BA bisects CAD. So if that is the case, it means this angle is equal to that angle. Okay, not a problem. And then D1 is 37 degrees. That's great. All right. So what do we do with this diagram? We will see that essentially that D1 is equal to this angle that we are looking at here, that A1. Maybe let's use that color. Why is that? If we look here, we will see that arc BC subtends D1 as well as A1. So these are angles in the same segment subtended by arc BC. There's no chord, it's an arc. And that means A2 is 37, which also means A1 is 37 degrees. All right. Now what we also know is that these are the so-called radii. We know that DF is equal to FA equal to FB equal to FC. These are all radii. And if these are radii, it means these angles are equal. These are angles opposite equal sides. Angles opposite equal sides. Those become isosceles triangles. And if we look at these two, they are simply congruent. Why? Because you can see that this side is equal to that side, that angle is equal to that angle is equal to this and that. So literally, these are congruent triangles. They've got two sides and two angles. I mean the third angle. It makes them similar first, but they are effectively congruent. Okay, that's something to notice. But again, you don't want to go too far at some point. You just want to keep it simple. We also know that now that C1 will also be equal to angle C2. Okay, our diagram is a bit decorated now, but I'm sure we highlighted what we needed to. Let's try and answer the questions. Determine with given reasons any three other angles equal to D1. So we can see D1 is equal to A1, A1 is equal to C2, as well as A1 is equal to D1 is equal to A2, which is also equal to C2, but also A2 is equal to A1, and there's another one there. So that's why the question says any two. So this is easy. 9.1. Can you see analyzing the diagram often gives you the answers quick? You don't have to sweat, but if you start looking for those, you might find yourself in a curve out of commission. You know what happens when that happens. So we can say, look, A2 is going to be equal to angle D1. The reason is that these are angles in the same segment. Okay? Subtended by arc BC. Great. We are done there. So we can say therefore angle A2 is equal to 37 degrees. That's the first one. It's an answer on its own. So maybe we can say this is Roman figure 1. Roman figure 2. What else do we know? We know that A2, we know that A1 is equal to angle A2. What is the reason here? We know that BA, we were told that BA bisects CAD. So that means those two are equal. So we can make a conclusion that therefore A1 is also 37 degrees. And then the third one can be of our choice. We can say here, we also know without a shadow of a doubt that basically D3 is equal to A1. Okay, what is the reason here? These are angles opposite equal sides of triangle DFA with radii DF equal to FA. At times, when you don't have a chance to say a lot of things, just complex them. It is fine, okay? Therefore, D3 joins the club of 37 degrees. Nice and easy. So 4 marks here is being scored. So we get a mark for the reason and the answer. This one only 1 mark because that reason is weak. Well, this one is also weak because that reason is a grade 9 reason. It is not really preferably going to get a what you call. It doesn't get a mark per se, but we can award if the question allows us to. All right. Now we need to show that DG is equal to GC. DG equal to GC. Well, we can see the vibes here are that of a line from center to midpoint of chord. So that means if we can prove that this angle here, for example, is 90 degrees, perhaps maybe let's look at the other one. The other one is going to be easy to prove. Let's prove that that angle is 90 degrees. And if we can prove that that angle is 90 degrees, then we know that a line from center perpendicular to chord bisects the chord. So that's what we need to do here. All right. So let's look at that triangle. So this is this triangle DGA that we have to look at. So we already know A1 is 37, we know D3 is 37, but we also know something, that that whole angle is 90 degrees. You see? So that means if that angle is 90 degrees, we can calculate D2 by subtracting those other two angles. And once we find the size of D2, we can then use this triangle to work out G1 from three angles of a triangle. And if that comes out as 90 degrees, we are the winners, are we not? Yes. So we're going to say here, in triangle DGA, what do we see? We know that angle ADB is equal to 90 degrees. Why? This is the angle in the semicircle. Okay? We were told that BA is a diameter, so that already sets us up nicely. We know also that also that, can you see sometimes talking and carelessly writing? So we know here that, guys, D2, sifuna D2 is going to be 90 degrees minus D1 minus D3. Okay, that's just the setup. So this is 90 degrees minus 31 degrees minus 31 degrees. Can you see? It's working out just fine. Therefore, D2 is going to be 90 minus sembhalo 31 abavela phi manje. Yabona ke. Maintain vigilance, guys. 90 degrees minus 37 times 2. It gives us 16 degrees. All right. So we needed that D2. Okay, but we really did need that. Perhaps I should have just done that before I zoom into this triangle. Can you see that? Yeah, man. Yeah, man. Maske singaqali ngawe statement. You are usually a good statement, but at this point, you are a wanderer. You are a wanderer. So we can say then, in triangle, now let's say it DGA, sesifikileke manje, sesigalelekile. We know that technically angle A1 plus angle D3 plus angle D2 plus angle G1 must give us 180 degrees. This is the sum of three angles of a triangle, this one. Now A1 is 37 degrees. D3 is 37 degrees plus 16 degrees plus G1 is equal to 180. We can say therefore angle G1 is going to be 180 minus the sum of those angles, 37 times 2 plus 16 is 90 degrees. Holy cross. Which is definitely 90 degrees. Now that we have proven this, we can say here, therefore, we can appreciate that DG must definitely be equal to GC. This one is the converse of line from center perpendicular to chord. Okay, because normally we get told this is perpendicular, then we can say it bisects the chord. But now we saw that this is perpendicular. Why did it converse? It's not converse. There's no converse here. Yeah, there's no converse. Sesaqhele converse straight. All star igcwele apha entloko iyaduma. We can say line from center perpendicular to chord. So this one is more of an anterograde situation. We're not working back, we're working forwards. All right, guys, so that was a bit nice-ish. So I also taught my students on Saturday how to prove this theorem and how to apply it. So I'm sure they must have smiled when they saw this one. They were like, we are chowing it. We are chowing it. Now, this was a significant story. But the other big deal is the answer for D2. Okay? And essentially, this statement is important, and to prove that G1 is 90 degrees was key. Everything else was a means to an end, so not really giving marks. Okay, guys. Nice and scrumptious. 9.3 says, if it is further given that the radius of the circle is 20 units, calculate the length of BG. Where is BG? BG is this length right here. Okay, that's not a big deal. We can calculate BG. Because we now know that angle D2, now let's look at another triangle to do our gymnastics on. So if we look at this triangle, so guys, master these diagrams because they have everything in there for you. Can you see we've got 90 degrees there? Now, we understand that the length of the radius is basically FB. Can you see FB is going to be the length of the radius? Now, if we find FG by using this triangle DFG, we can actually work out that side pretty easily. So let's see first that in triangle DGF or DFG, we have proven a lot of things there. So, but mind you, we have that angle D2 as 16 degrees. Now, if we've got that angle, so remember the radius is also the hypotenuse here, which is also 20 units. And we want the opposite side. We've got the angle, we've got the hypotenuse, we want the opposite side. That's trig ratios there. Sine of angle D2 is going to be FG over DF. That's just sine. This implies that sine of 16 degrees is equal to FG over DF is 20 units because it's the radius. Therefore, FG is equal to 20 times sine of 16 degrees. Let's do it. Sine 16 times 20. Now, we will have to round off to 2 decimal places here. This is going to be 5,51 units. Remember, this is a distance. Now, after that is sorted, we can say then we understand that FG is equal to 20 units. This is the radius of the circle. This implies FG is made up of, no, did I say FG? I meant to say FB. We know that this is made up of FG plus BG. This is 20 degrees, which also implies that 5,51 plus BG is equal to 20 degrees. Therefore, our BG is 20 degrees minus 5,51. So 20 minus 5,51 is 14,49 units. Right. So there was no specification as to how that must come out. So we rely on the general instructions, which by now, if you are my student, you should know that you start here when you write an exam. And those you cannot compromise on. Okay? So can you see it says 2 decimal places unless otherwise stated. So please read this instruction, because when it comes to questions like this, it's easy to throw away marks, which you could easily just walk away with safely. So guys, how many marks? 4 on offer. What matters is finding FG here. Right? Right, and this answer here. And then what are we going to say after that? We can give you a mark for the gymnastic. Why not? It seems like someone was happy here. So we can say here, maybe substitutions. I don't know. Someone was generous here. Guys, benibuzwa into ezilula man, yazi. Benidla ama-cry nice nje. Angazi kwenzakalani. I-exam enjani nale. Bedilidela uba izoba nzima, because upaper 1 naye nje bingama-cry nice guys. Manje banikeza ama-cry nice safuthi. Hayi. They want us to vote ne. Bafuna sivote. ANC ke le. I-ANC bakwemoto yokusibhayizisa ngoba bafuna abantwana abapasa ukuthi yabona under ANC kuyapasa siphela kabi ni sanukehlisa standard se-exams zethu. But ke kodwa guys, to be honest, this is a fair exam. This is what you expect when you study as a student, so that you don't find that you are studying for nothing. There's nothing we're going to gain by failing as many students as we can. I mean, standard grade material is good, because it means you can meet the standards that we need to improve our society. It's not about, excelling per se. Because, I mean, how many of the excellent people actually make a difference in life? How many? How many of them even? There's not so many. So, yeah, we need to make sure that we don't sink people, but we elevate them. So this is a good exam, actually. Don't hear me talking nonsense. In fact, I'm going to vote the ANC. So, nabani ngathini. Nangeke ndilahle ekhaya ngenxa bakubolile nje kuqela izibhanqa apha ngaphakathi. We have to fix it or die with it. I'm not saying it right into yenziwa yi-ANC, futhi andiyi-support into yenziwa yi-ANC yokuba imali. Kodwa masiyiqondeni into yoba i-ANC seyingasaphumeleli nje ngenxa bakhona iimpuku phaa ngaphakathi ezifakwe ngabanye abangaphandle bafaka imali. Ngofaka imali uzobona basimoshela iphathi yethu. La phathi ayibolanga le. Iboliswe ngaba abanomona woba soze baphinde basondele kuphatheni elizwe. Ngoba i-ANC iphathi efake abantu bonke baseMzansi. Khona belungu phaya, khona amandiya, khona amakhaladi, khona abantu abamnyama, abenhlanga ngenhlanga. zabantu abamnyama bakhona. Sendithi uba it's a multi-racial, multi-tribal party, ANC. So akekho umuntu ebezoyidefeata that easily. That's why bezama ukuyihlekeza, bayihlekeze ngokumane beblame yona for izinto ezenzekayo apha ezweni. And yet kune-external forces apha ezizosimoshela iparty yethu so that sizothi xa sesiqhekekile bathole ichance yokusilawula. Seyiyenzeka loo nto. Abantu bethu abacinga uba basmart bayamosha ngoba bathetha kakhulu. I am serious. At the end of the day benzani bona into nebhadlile abangasikhombisa abayenzayo. Hayi sinikeni ichance because balambile abo damn it. Qhela kabi. Minyathele emqaleni thina sinaxesha lokubhanqa. Anyway guys, let's stop politicizing. But it affects us all, unfortunately. We have to face it whether we like it or not. Asenzo question 10. We are told in the diagram COD is the diameter of the circle with center O. Again, do you see that? Diameter. Ilapha lento. So where is this one? COD. Masibhale. Sizoyibona. I don't need to write it. Yazicacela. But into esiqiniseke ngayo is that a diameter always subtends a right angle at circumference. So that angle, B1 and 2, is 90 degrees. Okay, EA is a tangent. So I like to highlight my tangents. Andiyazi le yenzeke la. Sekufuna ukuqhelwana kakubi nje. Esithubeni. Funa ihlale phezu kwawo lo mgca. Yeah, ingazocekisa apha. Now let's go. AO is perpendicular to CE. It's complicated nale diagram. I hate busy diagrams. OA is perpendicular to CE. Okay, there is that 90 degrees there is shown. All right, diameter COD, same diameter we spoke about, produced intersects the tangent at E. Okay, they come together there. OB produced intersects the tangent. So OB produced intersects the tangent at A. We can see that. CF intersects OB in T. CF intersects OB at T, not in. Aye, sesilungu esinjani? At bafana ba sanusiqhela. CB, BD, OF, and FD are drawn. Okay, that means these are straight lines essentially. Okay guys, what can we do here? Well, we've got some 10 chord story, because can you see we've got an angle between the tangent and the chord. So we can see that we've got this angle between the tangent and the chord. So that satisfies the 10 chord theorem. We've also got this angle between the tangent, this tangent and chord. The angle is C2. Okay, there's a lot of things here to consider. But we know stuff that this is a radius. This is a radius, meaning CO and OD are a D as well as OB. These are a D, okay? So making these triangles isosceles, meaning this one must be equal to that one. These are angles opposite equal sides in that triangle. Is there any other? Oh, there's another one. This one is a radius. I didn't indicate. So there's a whole lot of things. Hi guys, yabona mase kunjeke kuyamosheka kuvele kumosheke kakhulu. So ngelinye ixesha asike siyeke ngoku seyifuna ukuba nento ezininzi ezasimosha. I think once we have done a bit of justice to our diagram, we can go far. We can also appreciate an extra thing here, that C2 is going to be twice O2 is going to be twice C1, angle at center equal to 2 times angle at circumference. There's a whole lot of structures, honestly, to look at here. But now this diagram is too busy. So when it is this busy, I think what we have done is good enough. So let's have a look and see what is our next move. Let's answer some questions. 10.1 says, prove with reasons that TODF, where is that? TODF, okay? Okay, so we see there is that TODF, okay? Nice. We need to prove it's a cyclic quad. Okay, that's easy. We already have the exterior angle 90 degrees. We know this is the diameter. So this angle as a whole. So can you see this angle as a whole is also 90 degrees. Angle in the semicircle. Even though we saw that one first, there is the one that helps us. Okay. So if that is 90, that is 90. Therefore, this is a cyclic quad. The exterior angle is equal to the opposite interior angle. So that's fairly simple. So we can say here, okay, do we really need to say much? Let's just jump in and say F3 plus F2. Or maybe let's just make it look fancy-ish. It's going to be DFT is equal to 90 degrees. Why is that? This is the angle in the semicircle. Nice and easy. Okay. We can say also, we know that angle O1 is equal to 90 degrees. That is given. We can conclude, therefore, that DFT is equal to angle O1. H is 90 degrees. Right. We can then make the conclusion, therefore, that this TODF is a cyclic quad. The reason is that we proved the exterior angle to be equal to the opposite interior. This is the converse of exterior angle of a cyclic quad. Okay, nice and easy. Nice and easy. Yeah, guys, this was more of a standard exam, truly. I can tell you. So this was a mark, and essentially that statement and reason is a mark. So 2 marks, and then we are getting 4 marks. Yeah, when I can go. Sure, I asikunike ke mntwana esikolo, because it's not, but sometimes you get 2 marks for the statement and reason. It's not always 1 mark. You get 1 mark for the correct statement, 1 mark for the correct reason. And I would rather I'm sure these marks are distributed like this: statement and reason 1 mark, and also here the reason 2 marks. Anyway, doesn't matter, guys. You will come to know how these marks are distributed once the formal marking guidelines come out. Now we need to prove that D3 is equal to T1. D3 is equal to T1. Okay. So how are these related? Look, T1, let's look for a nice color. T1 is itself vertically opposite that T3, right? But if you look at T3, it's an interior angle on that cyclic quad. But we know that this line is extended, so that should be equal to D3, the exterior angle of a cyclic quad. So this exterior angle of a cyclic quad is becoming popular. So can you see? Yeah, when the diagram is so busy, look, none of what we discovered has been put to use as yet. Okay. We are discovering new things as well. Okay, so we know that. Let's start with D3. D3 is equal to T3. Right. This is the exterior angle of cyclic quad TODF. Okay? We will say but one ten is strange. But we know that this T3 is equal to angle T1. These are vertically opposite angles. Right? These are straight lines that intersect. So we can make a conclusion that therefore T3 is equal to angle T1 because each is equal to angle T3. Nice and easy. So they were asking fairly easy questions, eh? Yeah, fairly easy questions. Pretty standard stuff. That's what we expect, man. Guys are studying so hard, man. Paying hefty fees for tutoring. And then they go and fail a nasty exam. So that is good. We hadn't spoken about it. And we know that that is good also. We didn't speak about it. And then we can give a mark for the last one. Okay, guys. So that is proper stuff. 10.3 says we need to prove that triangle TFO. Where is TFO? Okay, there is our TFO, that yellow triangle there. Is similar to triangle DFE. So there is our DFE. Okay. All right, okay. So we need to prove that these two triangles are similar. So what do we know? We already know that this T3 is equal to T3. We've just proven it. So that's fine, one piece. Then if we look at F4, 10 chord theorem links us to C2, which is equal to F2. So essentially, these two are equal. Once we prove two pairs, the third pair pretty much fits in nicely. So we can do that. So we can say in triangle TFO and triangle DFE. So what do we see in these triangles? Well, what we see in these triangles is this story. Looks like I'll have to clean the canvas. I was busy with other lessons here. Let's quickly get these ones sorted. So we'll start with D3 because it's already given. So we know that D, by the way, TFO is that one. So we can say T3 is equal to D3. Okay. This is proved above. We don't need to use that again. Okay. We can say also, we know that, maybe let's not say also. This thing is creeping in. I was doing that tutorial on your paper one, guys, so it looks like I didn't clean completely here. Okay, so this says for us we can use F4, but now we will start from C2, right? Because C2 is the link between these two triangles. We can say, look, okay, maybe let's start with F2. We can say F2 is equal to angle C2. Why is that? These are angles opposite equal sides in triangle COF. COF, okay? Maybe we can say here to convince the examiners is that we know that with ready OF equals OC. There's nothing wrong in saying a nice reason. Ne? Yeah. Then we can say, but we understand, secondly, that angle C2 is equal to angle F4. That is the 10 chord. Theorem. We can say, therefore, we are happy now to say F2 is equal to F4. Right. Obviously here H is equal to C2. C2 was the link. Okay. And then we have proven two angles. We can make a conclusion and say, therefore, maybe this implies, which will also imply that essentially O2 in the other triangle is equal to angle E in the other triangle. Remaining angles, or one can say three angles of a triangle, or sum of three angles of a triangle. Therefore, we know now that TFO is similar to triangle DFE. The reason is that it's a triple A. Abdominal aortic aneurysm. Yabona. Ungazosiphaphela ngamagama amakhulu la. Cinga singobani. We are just maths fanatics. Nothing big. Okay, let's go, guys. How many marks here? 5 marks. Really? These guys, they're not serious now. Perhaps this one is strong because it's a bit of a diversion. And then the 10 chord theorem. And then eventually linking those two. Probably. Then we can mark the remaining angles and the final answer with the reason. Not a problem. So somebody felt a bit generous there. Sometimes big marks don't really translate to difficulty in solving, eh? Yeah, they're proving us wrong with this one. Now we're told if B2 is equal to angle E. Okay. If B2, now let's remove this 90 degrees of ours. Doesn't look like it helped us anyway. So, what are we told now? We are told that B2 is equal to angle E. Alright. And obviously this would mean it is also equal to angle O2 then. Because that O2 we found out to be equal to E in a way. Okay. Now, we are to prove that DB is parallel to EA. Okay. Yeah, maniac, that's pretty strange-ish. How on earth is that going to happen? Okay, let's have a look quickly. I mean, it's a 2-mark question. It shouldn't be difficult. There is the story. Looks like also this angle here didn't help us at all. Masisus. Yeah, sometimes what you do prior can work against us. Can you see it almost hid something important? Can you see OB and OD already? That angle B2 is equal to angle D1. Those are angles opposite equal sides. Yeah, here we're sitting at grade 8, grade 9 stuff, eh? And now we can see that if that's the case, it means that D1 is equal to E. These are effectively corresponding angles. So when corresponding angles are equal, it means the line have to be parallel. Okay. That was not so bad. 10.4. We will say here, we know that angle B2 is equal to angle D1. What is the story? The story is that these are angles opposite equal sides in triangle BOD. We know that with radii, OD is equal to OB. All right. Now we've justified that. We can say since angle B2 is equal to angle E, this is given. It therefore concludes for us that actually now angle D1 is equal to angle E. H is equal to angle B2. Great. We can then make the conclusion that therefore DB is parallel to EA. We can say corresponding angles are equal. Okay. That is good. That is good, guys. So we are done with this question. So I guess this is a strong one. The given ones are not a big deal. The answer perhaps with the reason and everything else linked everything nicely. All right. So technically no suplexity whatsoever here. All right, 10.5. Prove that DO is equal to TO. Okay, now let's find out where is DO. DO is this side. And then it's going to be equal to TO. TO is that side right there. Okay. So TO is that part of that triangle, one of the triangles that we proved, all right? FE is part of the other triangle in the similar triangle, so it's always going to link to them somehow. AB is this guy. Now this is the suplexity, obviously. Now I can feel it, it's coming. So ungenapo B. Because we can see these ones, definitely we can see these ones, but not the O40 is a bit off center. But if we look at these lines we just proved parallel, they create for us a triangle AOE with DB drawn parallel to EA. So that means the proportionality theorem. Okay. So we can look at that triangle, essentially. So let's look at that triangle. Let's highlight it blue. Yo, ifuna ungixelela ba lento iso straight line. Hayi wena, singiqhela. Yo, ayisiso nyana. So they drew it in a computer laba. Yo ndageza bafethu ndiyaxolisa. Andingomuntu ogezayo. Kanje ndiyazithethela kakhulu, ngithanda ukuthetha. Okay. So can you see, guys, this one? Look at that. That blue triangle, it satisfies similar triangle. I mean, what you call? Yeah, similar triangles in a way. Or proportionality theorem, because those two are one and the same thing. Okay, let us try to use those similar triangles to get DO as part of the game here. So we know that, well, in triangle AOE, a vowel triangle, essentially, we can say here that DO over DE, because esifuna la BA or AB avele kamnandi nje, izoba ngu-OB over AB njengoba beyibhalile, but the best would have been BA. What is the reason? This is the prop theorem with DB parallel to AE. Number one. Now we want to isolate DO. So masiye ke bafana. Siye phasi sithi ke ngoku ithi into zethu la. U-DO wethu uzoba ngu-DE times OB over AB. Okay? Now, sino DO qha. Zethu zininzi. Akukho nenye apha evela. u-AB ukhona tyhini phantse ndabhayiza. So we've got only two things here, but now we've got two foreigners here. These sirs must go home. We don't want them here. Hey, ndiyadlala mfethu, sibafuna bonke bezela, siyabadinga. You know, most of our foreign friends, brothers and sisters, or whatever you call them, they are the reason this country is running in many ways. Look at the education system. They are the best teachers we have, you know. But ningakhula masiba namaphiko amakhulu ngenxa ndiyancoma nesiqhele kabi ningayenzi lonto. Siyanithanda kahle siyani appreciate thina sinankinga nani kahle akunamathata lelena. Fela halika di tshwara sharp le re tshware sharp le rena. Like nika ka lo wena ka lo nika mina yayibona lanto siphathane kahle man singaphaphelani qha. That's the one thing that matters. Now guys, we can see if we're not going home, that means we need simultaneous equations. Obviously these guys should do something. They have to do something. We know. However, in those triangles, sifuna FE, we can see FE is part of these triangles. So qala ngayo sithi, well, sizosebenzisa la FE kanye. Sithi u-FE wethu over, masibone, u-FE is opposite u-D3. Right, u-D3 was equal to T3 kwela cala. Then that is opposite u-OF. Sizothi ke ngoku over OF. Remember, the sides that make up the ratio are the sides that are opposite the equal angles. And then What else can we say now? Hey wena. Ngathi ufuna ukusiweka sana. By the way, we want DE, right? I-target here to sesilapha nje was DE. So that means DE must be here. So basically, I want DE. So masiqale kanje. Masiqale ngo DE. DE over. So now DE is opposite angle F4, which we found to be equal to angle F2. That is opposite TO or OT. So this is going to be over TO. Then see angle EF over EF is opposite OF. Nice. So what can we say here? This is proportional sides in similar triangles in 10.3. So guys, be flexible, man. Make sure your story holds water. So all we want is to cross multiply there. We want DE to give us UTO times EF. Can you see ziyavela ngoku ezisimphi? Inkinga izoba ngu-OF nje kuphela yena yedwa. Then guys, we can put DE back into that expression. We can say then with DO equal to DE times OB over AB. This will be equal to, instead of DE, we put that story. So this is going to be TO times EF over OF times OB. All of that thing is divided by AB technically. So injalo lento sengiyayibona kancane kancane. But guys, what do you notice? Do you notice that OB is the radius, OF is the radius? So ezinto ezimbini ziyafana is. So that means they can take care of each other like that. Nje kanjalo nje. Okay, masiqale sithi kuqala before sisuse. Sizothi here, but we know that OF is equal to OB. These are already, ne? So let's just sit again, go with that implies that would DO wethu ungubani uzoba ngu-TO. So qale siyibhale njengoba injalo andithi ngajahi. Sometimes ukujaha kuzokufaka enkingeni. Ukwazi uvela sosuse izinto singazazi uzisuselani. So funeka siphinde ingoma emnandi ngokuphindwa. Then ke ngoku we are allowed to do the things that can be done. If you can get what I'm trying to get to. So it comes out nicely now, guys. TO times EF over AB. And that is done. So simultaneous equations, guys, are always there. So I'm sure students here suffocated a little bit. But yeah, if you know maths and you've been doing these higher order questions, this should not be a big deal, because you just know when you get to this question, you're going to do an essay of maths. There's no excuses here. All right, so that 5 marks was a bit. This statement and reason is key, and finding DO is key, and that statement and reason is key. Finding DE was also key. Now substitutions, guys, is not a big deal, is it? I am sure though that this step is critical, although we don't really mark gymnastics, but I think those gymnastics were key there. So this is how many marks now? 1, 2, 3, 4, 5. Yeah, the final answer, remember, was already volunteered, so no marks for it. Okay guys, that is it. I will see you some other time. Goodbye. Stay tuned for the other questions that I think I will show you. I think I should do trigonometry. I've abandoned trig for a long time, so I'm gonna show you some trig questions as well, so that those of you who are writing the media exams are ready. Okay guys, bye bye.